All right, in this video I'm going to show you how to solve for the density of a gas at a certain temperature and pressure. In this particular example, we're going to be solving for the density of carbon dioxide gas. So when we're talking about gases, it's important to note that density is going to be given in terms of, density will be given in terms of grams of the gas divided by liters of the gas. We use liters when we talk about gases because gases take up a lot of space. So rather than use small units like milliliters, we're going to use large units of liters. So in this case, since we're solving for the density, we're going to use it like it's a formula. Grams divided by liters. So we need to solve for both of these, plug them in, and then solve for the density. So looking at the question, it almost looks as if we don't have enough information. We don't know how much gas we're talking about. So when that happens, you're going to assume something that will make your life easier. And for this particular example, if we assume that we have 1 mole of the gas, then it simplifies the math, simplifies what we're trying to solve for. So if we assume that we have 1 mole of the gas, figuring out the grams of the gas is straightforward. The molar mass of carbon dioxide is 44.01 grams per mole. If we assume that we have 1 mole of the gas, then we know that we also have 44.01 grams. So I'm going to put that in. That's our numerator, 44.01 grams of the gas. Now we're going to use PV equals nRT to solve for the liters of the gas. So I'm going to collect up my variables over here. Pressure is 1 atmosphere. Volume is going to be what we're solving for. N is the number of moles of the gas. We assumed that we had 1. R is the gas constant, 0.0821 liter atmospheres per mole Kelvin. And temperature is 20 degrees Celsius. Now remember, make sure that you have the right unit before you plug things into the ideal gas law. The ideal gas constant tells you what those units should be. Liters tells us that our volume will come out in liters. Atmospheres match. Moles match. Oh, we have to convert Celsius into Kelvin. So Celsius plus 273.15 gives us that temperature in Kelvin, 293.15. Now we're ready to solve for volume. I like to rearrange the gas law equation before I plug numbers in. So in this case, divide both sides by V. The volume of the gas is equal to the moles times the gas constant times the temperature divided by the pressure. As long as all of my units make sense and are correct when I've written them down up here, then I don't have to worry about writing them down in the gas law equation. So in this case, volume is going to be equal to 1 mole times 0.0821 times 293.15 divided by 1. The volume of this gas is 24.1 liters. So now that we know the volume of 1 mole of gas, we know the mass of 1 mole of carbon dioxide gas, we know the volume, 24.1 liters. We can plug that into the equation, 44.01 divided by 24.1 liters. The density of this carbon dioxide gas at 20 degrees Celsius and 1 atmosphere is equal to 1.83 grams per liter.